Greetings, everybody. Hope everybody's doing well. So we're going to get into lesson 5. Okay, we're going to get into lesson 5. So for this lesson here, we're going to get into a new topic. Okay. So we're going to start with energy transfer in. So we're going to get into energy transfer. Energy transfer in electrical systems. Okay. Electrical system. Okay, so here we are going to talk a lot about a movement of charges inside electric circuits because the energy is transferred through the movement of charges. Okay, so there are 3 subtopics over here. Okay, so there are 3 subtopics that we have to cover in this chapter. Okay, circuits and current electricity. Circuits and current electricity. Components of a circuit. Effects of an electric current. Effects of an electric current. So these are the 3 subtopics that we have to look at for this chapter, energy transfer in electrical systems. Okay, so let us begin with circuits and current electricity. Okay, without any waste of time. Okay, so we're going to start with circuits and current electricity. Circuits and current electricity. So we have to understand firstly what is. It's important to understand what is an electric current. Okay, what is an electric current? So we define it this way. Okay, we say an electric current is the movement of charge in a closed system, or in a closed conducting circuit. Sorry, in a closed conducting circuit. In metals, the electrons are able to move freely. Are able to move freely within the metal. The electrons are not associated with a particular atom in the metal. In the metal, so we say electrons in a metal are delocalized. So this is the key word here, delocalized, because they are not associated with any particular atom. Okay, so they are delocalized. So that's what makes them to move freely. So the diagram here, I will use a diagram here to explain so let's use the diagram here. Yeah? So it has positive charges, which are formed from the ions. And then we have electrons here. The dots here represent electrons. So the electrons are delocalized and they can move freely within the metal. Okay. So the ions are fixed. So here's the difference here. Okay. So the metal ion does not move. Okay. Metal ion in fixed position. It's in fixed position here, meaning it does not, there's no movement. Okay. In fixed position. And then the dots here, the dotted things here. Okay. So this is delocalized electrons that move freely. Delocalized electrons. move freely. So the electrons move here. They can move in any direction, to the left or to the right, depending on how the terminals are connected. So it will depend on how the terminals of the circuit are connected. Okay. So then another important thing to know here is that what? So conducting wire in an electric circuit, circuit is made of metal. It's made of metal. So if we supply it with a source of energy, we supply it with a source of energy and a complete circuit. Circuit. Electrons will all move in the same general direction. The same general direction. Through the wire. So what do we say here is that the delocalized electrons inside the thing will either move to the left or to the right. They will move in the same directions, all these electrons here. See? So um, this movement of electrons through a conductor is electric current. Is electric current. Okay. And then we also have to remind ourselves, okay, what do we know from grade 11, from grade 7? Okay. So there is facts that we know, right? What we know at this point, okay, from grade 7, because it's going to help us from grade 7. So we know a couple of things from grade 7, if you remember. So let's just remind ourselves here. We know that what? An electric circuit needs a source of energy. And this is a key word here. So without a source of energy, nothing happens. So this source of energy could be a cell or a battery. So nothing happens if we don't have a source of energy or a battery. This is just a series of cells. A battery is many cells that are combined and put together. What we also know, we know that cells have positive and negative terminals. And then, so what we also know is that what? A circuit is a complete pathway. It's a complete pathway for electric current. So a complete pathway for electric current. So the key word here is what? It's a complete pathway. So what does that mean? It means that there shouldn't be any open switches on the circuit. Okay. And the other thing that we know that's going to be important here is that let's do this. Is that the circuit must be closed because we want a complete pathway, okay? The circuit must be closed in order. So that's why we talk about a complete pathway here. In order for a device to work. So then, so we say what? We say an electric circuit An electric circuit is a closed system. It's a closed system which transfers electrical energy. So another thing is what? So a circuit is made up of various electrical components. Electrical components. So we will look into electrical components. Okay. So now the electrical components, we should look at them separately. Okay. So this is just a small introduction and a small revision. Okay. So this is the thing you need to remember from what grade 7. This is what we're going to use here. Okay. So yes, guys, we are going to now start on this chapter. Okay. Energy transfer in electrical systems. Okay. So in the next lesson, lesson 6, we're going to look at components of a circuit. Okay. Because there is a lot of components of a circuit, and we will look at them in lesson 6. Okay. And again, thank you for tuning in. Thank you for tuning in, and hope you tune in for lesson 6. Okay, we're going to look at the components of a circuit. Bye bye for now, and I'll see you in lesson 6.